Welcome back. This is part 4 of microservices and NestJS. In this video, we'll be using gRPC as the transport, and as I've alluded to before, it is quite different from TCP and Redis. So what is gRPC? Well, to be brief, gRPC is it's Google's version of remote procedure call, or their implementation of remote procedure call. And RPC is an approach to which we build APIs in a way that remote functions are called as if they were local. So no more sending messages back and forth. It really just looks like you're calling a local function. Let's take a look at a quick example to see what I mean by that. With TCP and Redis, we used an API that is similar to event emitter. We send or emit an event with a name and a payload. The server catches it and emits a response using this same event-style communication. gRPC, instead of sending untyped messages directly or through a message broker, gRPC is actually fully aware of the types that it is sending and receiving, and thus it can provide some type checking and generate type clients, which is really cool. In the code at the bottom, you can see that the gRPC client has a get service method, which will provide you with the service that you need. Once you have that service or a reference to it, you can make calls on it just as you would with an imported software library. And this is the first clear advantage we can see with gRPC. Through the proto-file definitions, which we'll dive into momentarily, gRPC can provide type checking. Now we can get IntelliSense with Redis or TCP by wrapping the client in a type service like we did in the previous videos. But it is limited as the type checking stops with that service class. If that service class had mistakes in it or was outdated, TCP or Redis would passively deliver the message. The gRPC server, on the other hand, is not so passive and would generate a type error. At least in theory. I haven't actually run into any type errors yet with it. Second, gRPC encodes messages to binary before transmitting, which is much more efficient than sending JSON text. How much better it is depends on what you're sending. In my experience, it's very common to see 2 to 10 times smaller payloads. However, in some circumstances, you can do even better than that. And lastly, the type definitions for the clients can be auto-generated for most languages. We're not going to be using that auto-gen feature in this video because it would actually take a lot longer than to just manually declare a couple of interfaces that we need. However, I probably will make a future video in which I cover that. If you're interested in looking into that now, I'll provide the link to the GitHub repo for the TypeScript generator in the description below so that you can check it out. Now, you've probably heard me say this before, and I'm sure you'll hear me say it again. Design decisions are about trade-offs, and it's important to know both the pros and the cons of any solutions. So, what are the disadvantages of gRPC? Well, I'm so glad you asked. For one, it is more complicated to set up than TCP or Redis. Not too much, but I mean, it is more complicated. Second, and this is a big one, the transmitted data is not human readable. So we get that increased efficiency by sending it in binary. However, when we send it in binary, we can't just monitor communication and see a nice formatted JSON object. It's going to be in binary. And also, there's no curl-like tool for ad hoc testing. So when we're developing the, like a REST API or something, and we want to test it, we can just write curl from the bash command line, hit that endpoint, get something back. Not so in here. You're actually going to need a gRPC client booted up. Lastly, gRPC, if you want to load balance your microservices, that's not going to work with all load balancers. TCP load balancers are fine. Those that load balance based on the HTTP layer, where you're getting information from the request and actually deciding how to direct it based on that, most of those will not work. That's because gRPC uses HTTP2 under the hood, and most of those application level load balancers, they claim to be HTTP2 compliant, and they are to an extent, but only to the extent that they accept the HTTP2 and then down convert it to HTTP1 before redirecting it. You can probably work around that, but again, it's just something to know before you dive in. So based on the information that we just covered, what are the takeaways? Well, I think gRPC is most helpful when number one, it's used by a lot of different clients from several different programming languages. Being able to auto-generate those typed clients for each of those languages is really nice and helpful. And that becomes a real pain when you're using traditional APIs. Second, if you have a lot of microservices with several methods, if you're using some public API of Google's, you're having to look through the docs to see what the parameters are you're passing, what the object's going to look like that you get back. Whereas with this, when you get that client that acts like a local class, the IntelliSense that pops up exactly what the params are, what you're going to be returning, is really helpful when you have a ton of microservices and you can't possibly remember what the function signature is or method signature is on each one of these. Lastly, when you're transmitting large amounts of data, even though it is a bit more of a pain to test and troubleshoot than good old JSON text, if you're transmitting large amounts of data, that smaller payload size can really be helpful, not only in the latency, but also if you're transmitting outside of your virtual net in the cloud where you're getting billed for this traffic, reducing that by 2 to 10 times could be a real benefit to your organization. The other takeaway is to be careful. gRPC can be more difficult to set up and maintain. It can also be more difficult to test and troubleshoot. Now, gRPC offers some great advantages. I'm not telling you not to use it. All I'm saying is just know the facts before you dive in. At this point, I think we've talked enough, and it's time to dive into the code and convert our microservice from using Redis over to using gRPC as the transport. If you haven't been coding along, I'll put a link to the starting point in the description below. While the process is more complex than using gRPC, the bark is worse than the bite. You do need to get familiar with proto files, which we're about to talk about. But other than that, it's really not so bad. I mean, don't let it intimidate you. So with that said, let's convert the server over first, and then we'll take care of the client. So here we are in the microservice server, and we're going to make the changes we need to convert this over to gRPC. To give you a heads up on what we're going to be working on, first we're going to update the config object in main.ts. Then we're going to add that proto file that we've been talking about, and then we'll make a couple of changes to the controller. So if I come in here to main.ts, you can see that in order to save time, instead of typing everything out, I've just commented out the old stuff and put in the new, and then I'm just going to walk you through it. Hopefully this isn't too confusing. So the first thing we need to do is add join, because we're going to need that. So we add join from path. And then in our config object, we change transport.redis to transport.grpc. In the options, we comment out the Redis options, or just get rid of it if you're following along. And then we're going to add package app, which you'll see where that comes from. That's a name in the proto file. And then we're going to give a path to the proto file. And what we're doing here is this config object is really just pointing to where the proto file is, because that proto file is really what the config object is for the gRPC server that's going to be running in the background. So no changes to the bootstrap code down here. So once we've got this in, the next logical step is to create that proto file. So let's go do that now. Now, if you've never messed with gRPC before, you've probably never seen a protobuffer file like this. Don't let it scare you. It's not that bad. It's just, all it really is a type definition file. If you've worked to make a type definition file for TypeScript, it's something similar. If you've ever made a GraphQL schema, this is very similar. So let's just go by it step by step. The first line is just declaring that this is a version 3 proto file, which is the latest version and what you should be using. The second is the naming of this package, and this one I just called it app. And that's where in main.ts we get the app from. So now we're going to define a service, and basically for every controller that's going to be exposed and providing methods, we should have a service here that we're going to map to it, right? So we only have one controller, so I'm just going to have one service. I'm calling it app controller so that it matches the controller that it's mapped to. For every method that's exposed or that should be mapped, we're going to have an RPC. So for every controller, we have a service. For every method that's exposed, we want an RPC. And this is just, we just write RPC and we get the function signature. The only difference being that we leave it capital here. We tell it what the params are, we tell it what the param type is, and we tell it what the return type is. And then down here, all we're doing is we're declaring what those types are. So what is number array? Well, it's just an object with a array of numbers, right? Array of doubles, actually. And what is sum of number array? It's really just a scalar value sum. Now, what does this repeated mean? What does this one mean? Quite simple. Whenever you have an array, you're just going to put the word repeated beforehand. So that says that it's an array of doubles instead of just a double. This is the name, of course, of the variable. And if you had multiple, like let's say we passed 2 arrays or something, right? So that we did something like this. We'd put this 2, meaning that this is the second argument. That's all we're doing is setting the order there. But we don't actually even need that, so let's get rid of it. So again, the package name, a service for every controller that you want mapped, an RPC for every method on that controller that you want mapped. This is just a type definition file. I will leave a link in the description below if you want to read more up on proto files, or because if you're going to make something bigger and better than this example, which I hope you do, you might need to look into that. I'll have a link for you there. But other than that, it's pretty straightforward. Again, very similar to like a TypeScript definition file or a GraphQL schema. With this made, let's make our last step on the server side, which is to modify the controller. Okay, I know this looks messy. What I want you to do is just ignore this up here. Don't even look. In fact, you know what? I'm just going to scroll up so that you can't look at it. And we're just going to focus on the class definition itself, right? So what has actually changed here? It's not much, really. The only difference is instead of message pattern, we're using the gRPC method decorator. And what we're passing here on the inside, app controller and accumulate, that is what this is how we're mapping to that proto file. So the proto file, we said we've got a service app controller that has a method accumulate. By doing this, we're mapping this to that controller, right? And here's something cool. So I named this the same thing as my class. I named that service the same as my controller class, and I named the RPC the same as the method. And if you do that, you actually don't even need to put this here because it'll default to that class name and that method name, right? So this will work as well. However, just to be very explicit, I'm just going to leave that as it is. But remember, if you match those names up, you don't even have to use that. And then down here in the bottom, the only thing we're actually changing as far as this method is concerned are the types. So the type passed to it is going to be an interface which matches what we declared in the proto file for number array. Same for the return type. We have an interface sum of number array, which is just an interface that describes sum of number array. For the return type here, you can see also I'm still calling this.math.service.accumulate. The only difference is since we're getting an object as the param, I have to do the dot data rather than just presuming that's data already. And also the return type, I'm just wrapping it in an object with a key called sum. So that's all we're doing. We're just replacing message pattern, we're replacing it with gRPC method, and we're changing our parameter and return type so that they're wrapped in objects. And now if I go back to look at the top, all we're doing is importing what we need to do that. And so instead of importing message pattern, we're importing gRPC method, and then we're declaring these two interfaces, which are basically just the original parameter and return type wrapped in an object with a key name. So that's it. Well, no, that is not it. So before we can do anything, I should have really said this at the beginning, but you need to add. So either do an npm install, or if you're using yarn like me, just add yarn add gRPC and the @grpc/proto-loader. I've already got those added, I believe. I'm almost sure. Or maybe not. Okay. And with that, let me save everything, and we should be able to run yarn start dev. And the microservice is listening. It looks like we're good to go. So at this point, we're going to switch over to the client and make the changes that we need to make there. So now we're in the client. If you haven't been following along, as always, I have a link to this in the description if you'd like to pull up this repo. The modifications that we're going to have to make to the client are pretty simple. The first thing I want you to do is there's a math service.ts. I want you just to delete that. We don't need it. That was that wrapper class that we made to manually add some typing with the message-based protocols. We don't need that anymore. So you can delete it and then go into your app module file and delete it out of your provider list. And delete the import as well, since you'll no longer need that. With that deleted, that contained the options object, but what we've done is just made that into a separate file. So you can go over to your server and just copy this, because it should be the exact same object. In fact, in a production environment, you'd probably be fetching this from some common location. We copy that options object over, and then we are going to copy the proto file over, the exact same one. Just copy and paste it over here. Again, that's probably something in real life that you're going to be fetching from a common location anyhow. That's one reason they use the exact same one. Then the only thing we're really going to have to manually add here is the gRPC interface. So I just made a quick little interface for that service that's being exposed by the proto file, and that includes an interface for that data object that we're going to send out. Just copy this down really quick, or if you're using the repo, you've already got it, no big deal. And then the only real work that we've got to do, other than this, just deleting and copying some stuff over and creating that interface, the only thing left is the controller. So let's take a look at that. Not too much of a difference here. The first thing you're going to see is that we're actually going to get rid of the constructor injection for that math service, because we deleted it out. We don't need it anymore. And then we're going to add two more private properties here. The first is a client, and we're going to import that microservice options from here. This is where we're importing that. So we import it here, and then we use the decorator that we import from NestJS Microservices, and we pass it that options object. And what that's going to do is inject that base gRPC client into there. But we're not done there. This is a two-step process, because that's just the generic client, which is going to give us one service or another. And I'll explain that momentarily, because the next thing you should do is implement onModule init. And then instead of constructor injection, we're going to use onModule init, and we're going to say this.grpc service, so this right here, is equal to, and then we're going to call this client and call this method called getService. We're going to type it with that interface, and we're going to say app controller is what we want, and this is tied to the proto file app controller. Once we have that down here, we can now use that with with IntelliSense. Just call it just like you would a local method. The only difference is, remember, we're passing objects now, so I did need to wrap that. Instead of saying data, we need to wrap that in an object. And just saying data works because, of course, that is the equivalent of that right there. As before, make sure you add this, because we'll need those libraries. And then let's try to start it up and see if it works. So apparently no errors. Next stop is to test it out. Let's go do that now. On my desktop, I have two terminal windows open. The one on the left is for the microservices server. The one on the right is for the HTTP server that is a client to that microservice. And here I have my Postman-like app where I can send a request to hit the HTTP app, which should in turn contact the microservice app. The microservice app will return the answer to the HTTP app, which will return the answer to me. That's if everything goes as planned. So let's start this up. First, I'll start up the microservice server. Looks good. So I'll switch over to the HTTP app, which is our client. Everything looks good there. And now I'm going to use Insomnia, which is my Postman-like client, to send a request. I'm going to try to add 10, 11, and 12, which should give me an answer of 33. If all goes well, I'll get an object with a key sum that contains the answer. And sure enough, I do. I get an object with a key sum that has the answer. Based on the logging that we've got going on, I can see that it hit here and then immediately hit here. So all is working, all is good. We now have though very simple, we have a gRPC server and client set up and working in NestJS. Now that we have our microservice up and running with gRPC as the transport, this series is officially complete. However, I don't plan for this to be the end. I'd like to add a few bonus videos that explore certain parts in more detail, such as how other languages and frameworks can use NestJS microservices. If there's something in particular that you'd like to see, please leave a comment either here or on the channel discussion page. So that's it for now. I hope you enjoyed this series, and please feel free to provide any constructive feedback that you may have at any time.